Welcome to this video on partial fractions. In this video, we're going to be discussing non-repeated quadratic factors in the denominator. And we're going to begin with just an initial example describing how to do the decomposition process, setting up the fractions themselves with the quadratic factors. So as you can see on the screen, I've got this example, and in the denominator, I have two factors there. We have x and then x squared plus 1 in parentheses as well. And as you can see, that first factor of x is a linear factor, okay? Because we have an exponent of 1 on that factor. And on the second factor, x squared plus 1, that's going to be a quadratic factor. And that's going to be a non-repeated quadratic factor because the exponent outside the parentheses is also a 1. But what makes it a quadratic factor is this right here. Since we have that exponent of 2, that's going to be a degree 2, so that's going to change the factor into a quadratic factor. And we have to deal with quadratic factors a little differently when we create the fractions initially. So, when we have our fractions, we're going to wind up having a fraction for this factor of x. So you can see that as it comes on the screen. And since that factor itself, since this factor of x is linear, you can see it right here, we're going to start our numerator 1 degree less, which would be a constant, so we're going to start at a. And then what we're going to do is we're going to put a plus sign in between the fractions, and we're going to have another fraction for the quadratic factor here, and you can see that pop on. And so here's the x squared plus 1, but when we create the numerator for that fraction, again, we're going to start the numerator 1 degree less. You can see that bx right there. So, we have a square, so we're going to go down to the linear. So that's why we have that x next to the b. And then again, we always have to account for the constant term in the numerator. So no matter where you start your numerator, you always have to account for that constant term all the way down. So that's why we have, the bx there. So we're accounting for the linear term, which is 1 degree less than the quadratic. And then we're going to go all the way down to the constant term of c. And again, there's the notation there. It starts 1 degree less and continues down to the constant term. If we were to go all the way through the process, what we would find is the answer to, or the decomposition to this fraction here would be 3 over x plus x squared plus 1. We're going to go through an entire process of decomposing the example you're going to see. So here's what we're going to work on. We have q of x equals 3x squared plus 17x plus 14. And then in the denominator, it's nicely factored for us. So we have x minus 2 times x squared plus 2x plus 4. And then we're just going to walk through the 7-step process. So number 1 is going to be factor your denominator. As I had mentioned initially, it's already been factored for us, so there's not much that we have to do for step 1. But you do want to identify your factors. So this first factor here, again, that's going to be a non-repeated linear factor because, I have a 1 here and I have a 1 here. So that's going to be a non-repeated linear factor. And then this factor here is going to be a quadratic factor because of that square. But it also is non-repeated because the exponent is a 1 on the outside. So, at this point, you want to identify your factors. Now we're going to go to step 2. And this is where we're going to do the decompose. We're going to set up our fractions. So I brought in the rational expression that we're going to decompose. And again, we're going to set up our fractions. So the first fraction is linear. It's going to be set up for the linear factor. And you can see we're going to have the x minus 2's here and here. And then since we have a linear factor, our numerator is going to be 1 degree less. So we're going to start with the constant. And we're going to end with the constant. And then we're going to have a plus sign in between. And then what we're going to do is we're going to have a fraction set up for this x squared plus 2x plus 4, and that's a quadratic. So there's that denominator. And again, since this is a quadratic, we're going to have to start 1 degree less, which is linear. So there's the linear part, and then we have to continue it all the way down to the constant, okay? And as you can see the note that pops up on the screen, make sure when you have a quadratic factor in your denominator, as I have here, make sure that you account for the constant terms. Sometimes we get into trouble when we create the numerator that, we only account for that, that linear term, but we forget to work on the constant. All right, so we're going to go into step 3, where we're going to wind up getting rid of the fractions, and we'll go through the rest of the process. So step 3 says multiply both sides of the equation by the denominator of the left side. And basically what we're going to do is remove the fractions. So here is the equation from the previous slide. It's exactly what we had in the previous slide. So all I want to do, and this is pretty much the step in all of these types of problems, what you want to do is you want to multiply by the denominator of this side, and that will wind up getting rid of the fractions. So I'm going to put brackets around the entire equation, and then we're going to bring in the denominator of the left side. You can see it right here. We have the x minus 2 times x squared plus 2x plus 4. And then all we're going to do is just distribute that into the parentheses on both sides. We're just going to multiply that all the way through. When I do that, these factors will wind up canceling. So on the left side of the equation, we're going to have 3x squared plus 17x plus 14 equals, and then on the right side, the x minus 2's will cancel, so we'll wind up having a, you can see that, and then we're going to have times x squared plus 2x plus 4, and then we have to do it one more time to this fraction, and then the x squared plus 2x plus 4's will cancel, and then what we'll have is we'll have plus, and in parentheses, we'll have bx plus c, and then times x minus 2. And then you'll see that drop right in, and that's exactly what I had written above. We've gotten rid of the fractions, and now we're going to clean it up a little bit. What we're going to do in the next step is we're going to distribute into the parentheses all the way across, and then we'll wind up doing some grouping. So we'll go on to step 4. All right, so now we'll head into step 4, where you can see it. We're going to expand the right side of the equation and then group like terms in parentheses. So I'm going to bring in the equation from the previous slide, and then all we're going to do is just distribute the a into the parentheses, and then we're going to do the same thing with the bx, and then we're going to do the same thing with the c. So when I distribute the a into the parentheses, we're going to wind up having, after I bring down the 3x squared plus 17x plus 14, after we distribute the a, we're going to have ax squared plus 2ax plus 4a, and then we're going to take care of the second group, and we'll have bx squared minus 2bx plus cx minus 2c. All right, and you can see that slide in there. We're going to have all that cleaned up. And then the next part of the step here says to group like terms in parentheses. So basically anything with a square, so you can see these right here, the ax squared and the bx squared, I'm going to group those. So I'm going to group ax squared and bx squared. And anything with an x to the first, we're going to group those. And then anything with a constant term, I'm going to just wind up grouping those. So the 4a and the negative 2c with my constants. So it would look like this. We would have our parentheses. We would have ax squared plus bx squared in the parentheses. And then my second grouping would be just x to the first. So we would have 2ax minus 2bx plus cx. And then the last grouping would just be the constant terms, and we would have 4a minus 2c. You can see that right there. We have all the groupings, and that's exactly what I had just written out. Make sure we group all the common exponents, all my common or common x variables, and then this constant group is in its own parentheses by itself. And the next step is where we're going to wind up doing a little factoring, and we're going to do some matching to create our system of equations. So we'll go to the next step. All right, so now we're in step 5. As you can see from the title there, we're going to factor and match to the left side of the equation. So let me bring in the equation from the previous slide. So this step, the first step is we're just going to wind up doing a little factoring. So you only need to factor the parentheses that have x's. You can see we're going to factor this one, and we're going to factor this one. This one here we're not going to worry about. I know I could factor out a greatest common factor of 2, but we're not going to worry about anything that's a constant parenthesis. So all we're going to do in this first parenthesis is anything with an x square is going to get, we're going to take out that x squared. We're going to wind up bringing it out and behind it. And then the same thing for the second parenthesis. We're just going to factor an x out and just bring it behind there. So we're going to, you'll see what the end result of that is as I have it slide into the screen. So again, I factored an x squared out of the first parenthesis. You can see it right here, and we're left with a plus b. And in the second parenthesis, we just took the x out. So I factored that out here, and we're left with 2a minus 2b plus c. And then the last one, again, I didn't touch that because that's a constant grouping, so here it is right here. And the next part of this step is we need to just match it to the left side. So if you've seen my previous videos, this is exactly the way I've done this step, whether it's been single linear factors or non-repeated linear factors, always in this step, I've pretty much done it the same way. So what we have is an equation right here. So the left side has got to be equivalent to the right side. So that means that this coefficient here, this a plus b for x squared, has got to be equivalent to this 3. So I'm just going to write that out here. We're going to wind up creating a system of equations. So we're going to wind up saying that a plus b has got to be equal to 3. And then this coefficient here, 2a minus 2b plus c, for this x, has got to be equivalent to this 17. So I'm going to write it like that. We're going to say that 2a minus 2b plus c is equal to 17. And then the last one, we have this constant group. Remember, this 4a minus 2c represents the constant term. And here's my constant term. So we're going to say that 4a minus 2c has got to equal 14. All right? And that's really it. So what we have is a system now. We have a system of equations, and we're going to wind up solving that in step 6. You see the animation as I link up everything. And it's exactly what I had shown. And here is the system as it pops in. And again, we have a linear system of equations that we're just going to wind up solving. You could use elimination or substitution at this point, in this next step, but I'm going to wind up going through, as you'll see on the next slide, I'm going to wind up going through the entire process using elimination. So that's where we're at. So we'll head to the next slide. The next thing we're going to do is solve the system from the previous slide. So I'm going to bring in the system, and what we're going to do is, you can see now there's a couple of different ways we could do this. We could use substitution. I'm just going to go through elimination, and I think what I'm going to do is, I'm going to pair up these two equations, and I'm going to eliminate c in the first step. So it says remove c, the uncommon variable there. So I brought in these two equations here. And I think what we'll do is I'm just going to multiply the top equation by a 2, and then we'll just distribute that into the entire equation. You can see that's going to come over here. So after I multiply the 2 into this equation, we have 4a minus 4b plus 2c equals 34. And now you can see that the c's can cancel. They have... we have the same number there with different signs, so I'm going to bring in my plus sign in my addition bar. And then when we do that, the c's are going to wind up canceling. And then I'm just going to have an a and a b. So when we add the a's, we're going to have 4a plus 4a is 8a. And then the b term here, it's just going to wind up coming down into the equation. So now I have an equation with a's and b's and another equation with a's and b's. So I can join those up. And then we can do elimination with those to eliminate a or b, and then we can, bring this together. So I'm going to solve for a or b. Here's the equation that we had from the last part. right here, and then I'm going to bring down a plus b equals 3. So I think what I'm going to do, now again, we could use substitution here. We're going to use elimination. I think what I'm going to do is eliminate the b's. So I'm going to multiply the bottom equation by a 4. So all we'll do is, we'll just distribute the 4 into the equation here. And you can see the multiplication. After I do that, so the top equation is just going to get carried over. I didn't touch that. And then the bottom equation, I multiplied all of those by 4. So you have 4a plus 4b equals 12. And now you can clearly see that the b's will cancel. So those are going to be eliminated. I'm going to bring in my addition sign and addition bar, and we can combine the a's. So we have 12a, and we can add 48 and 12, that's 60. And we can solve for a, so we have a equals 5. You can see that right there. We have a equals 5. Now I can substitute that 5 in for a in this equation, which that'll be step 3. So I'm going to bring that over. So here's the 5 from the previous step, and I substituted it in for that a. And then we're just going to solve for b in that equation, and we're going to get b equals -2. Now after you have the two variables, you can see this really start to come together. We just have to find c. So I'm going to solve for c, and I'm just going to use it. I could have used this one. I could have used the second equation, but this one seems a little bit easier. So I'm going to take the 5 that we found in step 2 in for a, and we're going to wind up solving. So we have 4 times 5. So, here is the 5, and I had substituted it in that equation. So we have 20 minus 2c equals 14. Now we're just going to solve for c. I subtract the 20 on both sides, so that's going to give me -2c equals -6, and we solve for c, and then we're going to get c equals 3. Okay? So now I found all 3 of my variables. Now the last step is basically just to put the partial fractions back together. We're just going to include these values in the numerators from step 2. All right, so the last thing we have to do is rewrite the partial fractions. So I'm going to bring in the fractions from step 2. And here's what we had from step 2. And if you remember from the previous slide, we said that a was 5, b was -2, and then c equals 3. And then all we're going to do is just substitute those values in for a, b, and c, and then we'll have the completed problem as it pops on there, flashes on the screen. So we said, 3x squared plus 17x plus 14 over x minus 2 times x squared plus 2x plus 4 is equal to 5 over x minus 2 plus -2x plus 3 over x squared plus 2x plus 4. So hopefully you enjoyed the video, and if you've missed any of my previous videos on this, in the first couple of videos I had done single non-repeated linear factors. I had done a couple of examples with single non-repeated linear factors. And then I had done a separate video on a repeated linear factor. And now I have another video here, as you just watched, on a single quadratic factor. So again, hopefully you enjoyed the video, and looking forward to catching you in all future videos. So please take care.